Yeah, so I'm going to give a quick introduction to modular blockchains. And there's four parts to my talk. I'm going to be talking about what modular blockchains are and their benefits, their progress in 2023, open problems, and the final destination of what we're trying to achieve with modular blockchains. So between 2008 and 2020, blockchains were basically fit into this sort of monolithic era where you had Bitcoin and Ethereum, which had a very similar architecture, where effectively you had a virtual environment. You had an execution environment. For Bitcoin, it was Bitcoin script. For Ethereum, it was the Ethereum virtual machine and some consensus mechanism. And those two things were kind of coupled together. So all the nodes ran the execution environment and executed every single transaction on the chain. And this wasn't scalable. So in 2019, this idea of decoupling consensus and execution started taking hold. And the general idea was, well, what if we had one chain that was only responsible for consensus and data availability, but the execution was offloaded off chain. And that's basically how rollups work. Rollups, they post their blocks to Ethereum or some other consensus and data layer like Celestia, but the actual computation and the actual execution and verification of those transactions happens off chain in the rollup chain itself. And the execution for those transactions is proven to the consensus layer using proving systems like fraud proofs or validity proofs. And that basically what you end up with that is a sort of a modular blockchain paradigm where instead of having the consensus layer and the execution layer kind of enshrined into each other, like Ethereum was when it first launched, you now have this modular blockchain ecosystem where the base layer is only responsible for consensus and data. And on top of that base layer, you have a wide variety of execution layers in the form of rollups. And those execution layers are modular because they can all kind of have different architectures and disadvantages and advantages, and they can use different programming languages. So, for example, you have non-EVM rollups. So your rollup doesn't even have to use the EVM. Like, for example, Slackware uses Cairo. And I'm going to decompose what the different layers are of the modular stack to discuss a little bit about the theory of modular blockchains. So, as I mentioned, first of all, you have the consensus layer. And what the consensus layer does in a nutshell is it basically takes in some arbitrary messages that a developer has provided and it orders them. It provides some ordering over them so that people can agree which messages came first. Because you need to know which messages came first to know if the same coin is being spent twice, which transaction should be the valid one. And then on top of that, you have the data availability layer, which is once those messages are actually ordered, we need to prove to the world they've actually been published. Because it's all well and good ordering those messages, but if we haven't verified they've actually been published to the network, then no one can actually know what the state of the chain is, what the transactions are, and do things like prove fraud if there's an invalid transaction in it. And this is actually very similar to kind of like what the Bitcoin white paper proposed as the central component of Bitcoin that makes Bitcoin possible, was this idea of a timestamping server. Like this idea where you can just take a hash of block of items to be timestamped and widely publishing the hash. That's the main core aspect of the blockchain. And so Bitcoin was kind of like on the right track there, but Bitcoin itself enshrined the execution environment. But the core component is the timestamping server. So the core insight of modular blockchains is what if we isolate that core component and allowed people to build their own execution environments on top of it. And if the base layer is is only trying to be responsible for data availability and consensus, then it can specialize more in trying to scale data availability in ways that are more efficient than if it tries to do everything at once. And that includes using techniques like data availability sampling, where you can guarantee or you can check and verify that most of the block is available and has been published by only downloading a very small piece of that data. And so that's a very good way to scale blockchains, because now it's no longer the case that everyone has to download every single transaction and the entire data of the chain to verify it. And then on top of that, you have the execution layer, which uses the base layer below it, which provides consensus and data availability. And what the execution layer does is it takes in those arbitrary messages that have been ordered and published, and then does some kind of computation on top of it to output a state. And what that basically means is if you assume those arbitrary messages are transactions, then it does some computation on those transactions, and then it outputs, for example, a table of accounts and balances. And that's basically the job of rollups in the kind of in a rollup centric ecosystem. They do this execution and they offload the data and the consensus to the base layer. And then optionally, you can also have a settlement layer, which is sort of like a special case of an execution layer that basically bridges other execution layers together. So if you have rollup A and rollup B, and they can use some settlement layer by posting their proofs to it, and that settlement layer can allow liquidity to flow between those two rollups. And so kind of acting like as a bridging hub. So if we put all that together, what is a modular blockchain? We define a modular blockchain as basically a blockchain that fully outsources at least one of those components that we discussed. So let's go through what are some of the benefits of modularity and modular blockchains. So firstly, scalability, because rollups now have their own dedicated computation environment, which means that instead of having a single chain where everyone's transactions are executed, and that was kind of like the original Ethereum world computer model, where there was a single kind of world computer and everyone's transaction is executed on the same chain, on the same computer, and that doesn't scale, obviously. But with rollups, if you spin up a rollups have their own execution environments. So if a transaction happens on rollup A, then rollup B does not need to execute that transaction. And so that's very similar to sharding. It's effectively sharding execution and is inherently more scalable. The other thing is that if you use techniques like data availability sampling, you can create a system where the more light nodes you have, then the more block space you can have, while still keeping the chain verifiable and secure. Because with data availability sampling, light nodes can contribute to the verification of the chain. The other advantage is choice. So imagine if when you're building a website, you only had one choice of programming language. Like, what if every time you created a website, you had to use PHP or Python, and you can't use anything else? That's very similar to kind of the status quo with the Ethereum virtual machine. People with modular blockchains and with the ability for people to create rollups, people can now experiment with better or more customized execution environments. So, for example, you can have a parallelizable execution environment. You can have a execution environment that is more suited towards a specific purpose. For example, there's a project called Curio, which has modified the Ethereum virtual machine to make it more suitable for like real-time games or executing real-time games on it by embedding the actual game itself as a opcode to the EVM. And there's also different types of rollups that you can play around with, like sovereign rollups or normal rollups or Celestiums, which are sort of like rollups that use Ethereum rollups that use Celestia for the A, or Ethereum L2s, I should say. And so users now have a lot more choice in choosing what kind of components they want to use in their applications. And then you also have this idea of sovereign rollups. There's a very big Cosmos ecosystem, but it's not viable for every time to create a new chain, you create a new validator set. So with sovereign rollups, it kind of gives you the best of both worlds because you can create your own sovereign chain without having your own validator set from scratch. So a quick overview of what the modular stack looks like today. There's a lot of, it's a very widely growing stack. You have different projects in all different categories, including there's 4 categories I mentioned, but also things like sequencer services, rollup frameworks, even rollup as a service providers. You can just go on the website, upload your code, and immediately deploy your own rollup chain in seconds. And various kind of cross-chain bridging providers. And so who knows what the ecosystem will look like in a year's time. So let's go through some open problems in the modular blockchain ecosystem. The first one is kind of like we need better UX for bridging, because in a multi-rollup ecosystem, bridging kind of becomes more of a pain for users, especially if there's many different rollup and application-specific rollups as well. Then payment systems for resources across layers. So if a rollup has its own gas token, and it also needs the gas token for the layer, there kind of needs to be better building for that to make it more seamless for people deploying rollups. There's also a lot of choices, so we need to make those choices easier to understand for developers. And maintaining the dependencies across the stack is also a challenge. And there's this idea of maybe we should define common interfaces. For example, a common DA interface for rollup frameworks instead of having a slightly different one for every framework. We also need to kind of like faster ZK proving systems and better developed fraud proving systems. I don't think there's any kind of completely deployed, decentralized fraud proving systems right now that's completely permissionless. And also privacy. This time you have an opportunity to actually try to enshrine privacy into the stack instead of just ignoring it. So what are some of the values of modular blockchains? First of all, light nodes. One of the biggest kind of disappointments of Web3 over the past decade is that everyone just uses centralized endpoints like Infura and Alchemy. But with light nodes, especially like using fraud proofs and sampling, we now have the opportunity to actually make it possible so that wallets connect directly to the peer-to-peer network instead of using some centralized RPC endpoint. We also have the opportunity to build a more positive sum ecosystem that's kind of like evolves past maximalism and have modularism, where different components can interact with each other while they're trying to compete with each other. And finally, I think the most important reason is because we're basically kind of stuck in this endless cycle of new layer ones. So every cycle, every crypto cycle, there's this new layer ones. So like in 2014, we had EOS, Cardano, Tron. Then in the previous cycle, we had Solana, Avalanche, and in this cycle, we had Sui and Aptos and Infinity, and they all promise to do something to have incremental improvement over the past cycle, but it's an endless cycle, and it's fundamentally extractive. So with the modular ecosystem, we can try to escape that cycle by having components that are reusable instead of having to deploy a whole new layer 1 ecosystem every time we want to make an incremental improvement. And so to summarize, and some of the values of summarize the values of modular blockchains. Firstly, users can be first-class citizens of the network by running light nodes. Secondly, we can escape maximalism and have a modular positive sum ecosystem. And thirdly, communities can choose to be sovereign if they want by having sovereign rollups, which give you the best of both worlds. So thank you.